So today you're doing solving matrix equations using inverse matrices, and in order to do this, you need to know the equation AX equals B. Okay, we're going to use that. We're going to use it this chapter, but we're also going to apply it again next chapter. Okay, so understanding this deal right here. Hopefully I can get this little pin thing to work. I got to find the pin. All right. Yeah. Yeah. All right. You want that. Okay. AX equals B. I'm going to reference those as matrices. So A is a matrix. X is a variable. B is a matrix. Okay. So the way we solve this, as we kind of referenced yesterday, the way you get rid of, like if you had the equation AX equals, I don't know, let's like, actually rather than A, let's call it, so I tried to do some things that I can make this a little easier. Let's say that was 6x, and this is 12 over here. If 6x equals 12, then x would equal 2. The way we get that is we do the inverse operation. We divide both sides by 6. The inverse of multiplying is to divide. Okay, so if that's the case right there, what we want to do here to solve for x is we want to get rid of that a. And the way we get rid of it is we do the inverse operation. Well, the inverse operation in matrices is finding the inverse of that matrix. So if I multiply a matrix by its inverse, tell your neighbor what you get.
Get the idea of the matrix.
Okay, volunteer. If I multiply a matrix by its inverse, Parker, you get the identity. Remember, the identity matrix is a matrix with those diagonal ones, right? So if I had a 2 by 2 matrix, and I'm dealing with identity, it's that matrix. In matrix form, the identity is the same value as having 1, as multiplying by 1. So this would be multiplying an inverse by itself to get 1, the identity. They're calling it the identity. Same thing as having a value of 1x, which is what we want. So 1x equals, and notice on this side, we have whatever we do on one side, we have to do on the other. Okay? So if I multiply this side by the inverse, I have to multiply this by the inverse. Now the big problem that some students will have is that they won't realize that there's a specific order right here. So I will harp on it today. When we correct tomorrow, I'll talk about it, but you have to multiply in that order. So in your notes somewhere, make sure you note that whatever the inverse is, that has to be multiplied in the first position. So it's A inverse, or inverse of A times B. It's not B times the inverse of A. Remember, multiplication is not commutative. So when I do this, that is not equal to this. You can't, we want this order. We don't want this order. Okay, the inverse has to be in the first position. Okay, any questions there? Yes, sir.
At the one at the very bottom, is there supposed to be a 1 next to it?
Right here. That's what the identity is. The identity is the same thing as 1x. So like in this equation right here, there's a 1 right here. We just don't show it. Right? So yeah, we usually wouldn't see this one. I mean, if you want, you could erase it. I can even erase it. Isn't that cool? I spent hours just sitting in my room at home working on this pad so I know how to draw on it. Pretty cool. Hours. You guys were working on health posters? I was working on drawing on this pad. That's all I did. Okay? I'm just joking. I wasn't doing that at home.
I thought you were.
No, I
Being
wouldn't do
serious.
that.
Oh, okay.
You start a life.
I do have a
I know
life.
he does, so.
I have dogs and stuff and kids and family that I sometimes see and stuff. All right. Here we go. Number 1 and number 2. Mixed side. These are the problems we're going to do together. I want you to find the inverse. Actually, I want you to complete 1 and 2 with your groupies right now. Okay? Go for it. What was the answer? That was lame-o. Okay, what's the answer to number 1? What is it? 1. Okay. Number 1. What's the answer to number 2? 1/2. 1/2. 1/2. Negative 1/2. 1/2. Okay. So we have our inverses. Okay. Everyone knows how to find the inverse. Tell your neighbor the formula to find the inverse.
1 over AD minus BC times the group.
Hold on, I'm recording here. Wait. I'm recording.
It's not times the original. I think it's times the
It is multiplied by.
Okay, what's the formula?
1.
Go ahead, Hannah.
1 over AD minus BC.
1 over AD minus BC, okay?
Yeah.
Times the, what do we call that other thing? Unbelievable. This is really the jumbled up matrix, right?
Yeah.
The messy matrix. All right.
Yep.
So the jumbled up matrix is what goes up here?
D.
Negative B. Negative C.
I don't know what that other line is.
A.
All right. Okay, so we're going to use that quite a bit today when you're finding your inverses. Now, in terms of what we're doing, anytime you have a 2 by 2 matrix today, you have to find you have to do this by hand. If you have a 3 by 3, you're allowed to use a calculator. Okay? So, when we're solving number 19 right now, okay, this is on the mixed side, so everyone copy that one into your notes. Number 19.
Oh.
Wait, so are we allowed to do it on the
No.
Oh.
No, you guys, I want you putting this in your notes.
Okay.
And you shouldn't be trying to show this work on your worksheet. For those of you that are worksheet showers, dude, get some paper. All right? If you don't have paper, there's some paper back there. That doesn't mean you shouldn't try to go get some. It just means that there's paper. Like, get some and use it. Tree made the ultimate sacrifice for you, man. All right. So this is A. We're going to call that A. Variable x equals b. Ax equals b. Okay? Now remember, in order to find the solution, we have to do inverse of a times a x. And that's going to be equal to the inverse of a times b. So the first step to solving this is to find the inverse of a. That's the first step. So what we did yesterday. Yes, Tyler?
That's not possible.
That's not possible?
There's no inverse.
How do you know?
That because 1 divided by negative 1 is 1, and 2 divided by is negative 1, and then 2 divided by negative 2 is negative 1.
Good. So if you're following along, if you compare the fractions, remember if we make these into fractions, those fractions are the same. 1 divided by negative 1 is negative 1, and 2 divided by negative 2 is negative 1. There's no inverse there. For those of you that weren't using the fraction form, you got sick of doing that because you're like, well, if it does work, I have to do AD minus BC. Well, A times D, that's that times that. That's negative 2. And that times that is also negative 2. Well, negative 2 minus negative 2, those two negatives make a positive, so that equals 0, and that 0 would end up right here. Tell your neighbor why it's not possible for you to have a 0 right there.
That's where the undefined comes in. This
That is.
Sweet. I get it now.
Okay, why can't we have a 0 there?
Because then you would be dividing 1 by 0, and you can't divide by 0.
Good. You can't have 1 divided by 0. That's undefined. Okay, it's undefined. All right, good job. So this one cannot be solved. There's no inverse, so no solution here. Okay, we can't solve it. No inverse. All right, number 21. Everyone copy 21 into your notes. Let's give that one a go. for those of you struggling getting started, remember this is A times X equals B. Okay? And so to solve it, you have to find the inverse of A, if it exists, multiply that by A to get your identity, which will mean you'll be left with 1x. And then you'll have to multiply B by the inverse of A as well. Alright? So first step is to find that inverse. Is it possible here?
Yes, it is.
Yeah. Okay. So to do our 1 over AD minus BC, so that's 1 over negative 2 times 5, or negative 10, plus negative 4 times 3, or
12.
negative 12. That's supposed to be a minus 12. Whoops. My fault. That's supposed to be minus. Okay? Those two negatives make a
Positive.
positive. So we end up with
1 over 2.
1/2. 1/2 times our jumbled up matrix. So D and A switch spots. So this up, whoops. This up here is 5. This is here
Negative 3.
negative 3 and
2. Oh wait, 4.
4. All right. Okay. So our inverse, remember this is just finding the inverse. 1/2 of 5 is 2.5. You could write it in fraction form, but if it terminates, I'm okay with decimal form as long as it terminates. So either 5/2 or 2.5. 1/2 of negative 3 is negative 1.5. 1/2 of 4 is, and 1/2 of negative 2. Now, how many were able to make it that far? Okay, good. That is A inverse, right? Or the inverse of A. You've got to now multiply that by, we know when we multiply it by A, we're going to get 1x, or just 1. So now we need to multiply this by B. Okay? Now I'm not a fan of a run-on equation, so I'm going to rewrite it down here. A run-on equation is if you'd say times 6/8. If you wrote that right here, just so you know, mathematically you've just wrote out an incorrect statement, and you'd have some teachers, professors, that would mark you down because they go, this is not equal to this. And you're like, well, that's not what I meant. I meant like I just want to keep I want to multiply by B here. So if you do that, you're writing an incorrect statement. You're like, so I got to actually rewrite all that? That's so stupid. What do I got to rewrite? Like it takes me forever to rewrite this new matrix. I mean, I got a 2.5, negative 1.5, negative 1, and 2, and then students are like, you happy now? And I'm like, yeah, actually I am. I am happy. So this is A inverse, and now we're multiplying that by our B. So 6/8.
Is equal to X.
Okay? Ends up giving us,
Something of that right now.
3
yeah, I'm gonna let you guys finish it. Let everyone finish it there. If you're done with that one, we have you're gonna finish the example side tonight as your homework, and then 2 more problems off the mix side. So for those of you who are like, I'm done, I'm waiting to go on, I think I've got it, you can just keep working through the rest of the example if you want, as long as you pause when we get to where we're at. For those of you still working on it and you need help, I'm going to be walking around just to make sure you're all in the... Here in class, I've zoomed in on this. This is number 21, right? So taking a look at this, just so that we're clear, this part right here, this equation, I'm finding out what x is right here. I'm finding that right here. Okay, so the x hasn't disappeared. I mean, x is going to equal A inverse times B, right? A inverse times B is what x is. That's what I'm finding out right here. So when I multiply these two things, 2.5 times 6 is
That would be 15.
15.
Yeah.
Okay, and negative 1.5 times 8,
12.
Negative 12.
negative
Negative
12.
12, yeah.
Okay, so negative 15 plus negative 12. And then I've got 2.5, or excuse me, 2 times 6, which is 12, and negative 1 times 8
Negative
plus negative 8. So my solution, I'm having a hard time writing out my 8s there. My solution should be 3 and 4.
So that's what x is equal to?
So x equals 3, 4. So, let me erase that box there. Okay? That would mean if I were to multiply 3, 4 times 6, 8, I should get that. Right? Or excuse me. If I were to multiply this times 3, 4, I should get that matrix. All right. Yeah.
Is there supposed something special with that? Because it's like you just divide by 2 for that second matrix.
It could just be a coincidence on that one. It's not
Okay.
going to be always that simple.
Oh, is that so simple?
Okay, any questions there? Everyone rate themselves 1 to 5.
Oh, yeah.
Okay, I'm going to try to come around and help out here in a minute. Before we do that, I want to make sure that, let me zoom back out here. Okay, I want to make sure that we can do these problems. These are the two off the mix side we're doing, 22 and 23. So right now, I want everyone to do 22, please. Okay, no talking about it. On your own, try number 22. Okay, time's up. Number 22. How many know the answer for 22? Okay, hands down. Okay, tell your neighbor what the answer is if you know it.
This?
Hey, time's up. What is the answer? Gabrielle?
4, negative 5, 3.
Good. The answer is right. The answer is right here. Why is that? Why is that our answer? Madison? You're multiplying it by an identity. An identity is the same thing as what number?
1.
1. I had a hard time with identity there. Identity. Identity. Okay, 1. So this is like having 1 in front of your x. So 1x equals 4, negative 5, 3. That means 1 times something equals that. Well, the only way to get that is to have x be that something. Okay, so x has to be 4, negative 5, 3. Yeah.
Oh, yeah, I was just saying basically, isn't the inverse of the identity the identity?
Yeah, the inverse of the identity is the identity. So if you would have done this and multiplied it out, hopefully you would have been frustrated out after the end because you're like, oh, dude, I had the answer at the beginning. Tyler?
I have a question about 23.
23? Yeah, 23. What's your question?
How do we do it?
Well, we first got to think about that as A times X equals B. Okay? What do you want to find?
The inverse of
Yeah.
A.
Good. We know that X is going to be equal to the inverse of A times B. We do it the same way. It's just you don't know how to find the inverse of a 3 by 3 unless you studied up last night. And I'm not going to expect you to do that by hand. I can show you that process if you really want to learn it, but you're going to use your calculator for it. So the first step is to put this into your calculator, and then use your calculator to find the inverse. I would put A and B both into my calculator. That way I don't have to multiply it by hand either. So right now, throw both of those in your calculator. Hey, ladies and gentlemen, I want your attention back up here real quick. So here's my calculator. Okay, if I go over, I'm going to edit. I'm going to just overwrite these. I need a 3 by 3. Okay. Make sure when you're putting that negative in, you're using the negative symbol at the bottom and not your minus symbol. Otherwise, you'll get an error here in a minute. Okay, and then I'm going to overwrite my second one is a 3 by 1 to put matrix B in. So negative 1, 12, and 20. And then when you're multiplying, remember, order matters. So we need to go A inverse times B. Inverse of A times B. So when I'm selecting these, I select matrix A, I find the inverse, and then I'm multiplying it by matrix B. You don't have to put the multiplication symbol. But there we've got it. Now how many got that? No?
Oh wait, let me.
You guys didn't get that?
No,
Uh-oh. What's that mean?
you did. You.
I could have done something wrong. Someone did something wrong. You think I did it wrong?
Yeah.
What did I mess up on?
I don't know.
That looks right. Matrix A. So yeah, maybe matrix B. So by the way, if you don't want to go into edit mode to figure out what you did wrong, I could just select B. Oh, I guess I'm in edit mode. Let me, I could just select matrix B, hit enter, and it'll tell me what I have in there. So what did I do wrong? Yeah, it should be a negative 20. Okay. Now, did I do that on purpose?
Probably.
I didn't actually.
Oh.
I didn't mean to, but it's a good teachable moment. I could have played along like I did. Yeah, that should be a negative 20.
Could have made it seem like you didn't mess up.
Yeah. So there we go. Negative 3, 1, negative 2.
Yep.
Now one little negative symbol screwed it up that much. Man,
Just a little.
that's messed up.
That
All
is
right.
messed up, man.
So x equals negative 3, 1, negative 2. All right. Now, if you do get an error message, like Alyssa was working ahead for me, and she did number 24 on the mix side. Is that right? Okay. Now, you don't have to do 24 on the mix side, but when Alyssa did it, she got an error. It actually just says error. Okay, it says singular MAT.
That means there's no inverse.
That means there's no inverse. Yeah. Okay, either that or you can't multiply the two matrices, like the dimensions don't match up. Okay, I would always just double check my matrices then, but for sure could be a no inverse on it, or the matrices won't match up in terms of multiplying A inverse by B. A quick like foreshadowing. It's an English term. I'm pretty impressed about it. Yeah, I'm trying to expand my horizons. A little foreshadowing here. Next chapter, the problem Alyssa did. You didn't even know this was going to be such a good teachable moment. This right here says this, like next chapter we'll study X, Y, and Z. This would be your X, your Y, and your Z. I tried to reference that yesterday. This is telling you that your X is equal to, or your Z is equal to 3 and your Z is equal to 4. That's why that's an error. That's not possible. Okay, so for those of you watching that right now, when I ask this next chapter, you'll know the answer. This says 1Z equals 3, and that says 1Z equals 4. You can't have them all equaling, Z equaling two different things there. Yeah?
Wow.
Didn't we do something like this in geometry last year?
You did matrices last year. You did
With, like,
translations.
triangles?
Yeah, right here. Geometry's doing it on the board behind.
Oh.
Yeah. Yeah. All right, very good.